finally here. I'm so happy to see so many of you taking the time to rest your legs and listen to my 15 minutes of company pitch here. So I'm Peter Davidson, and I'm here today to inform you and talk about a Danish company that makes microsatellite called Space INVENTOR. Anyway, a little bit about today's agenda. First, short about the Space INVENTOR company. Then I will tell you how we have positioned ourselves in the space market. I will talk to you about all the modules and parts that we use for our microsatellites, show you some examples of the satellites that we are currently building, and then finally ending my presentation. Anyway, so just to recap, Space INVENTOR, we are a full-scale supplier of microsatellites. Small company in the beginning there, 2 persons founded Space INVENTOR in 2015. And today we are, I could say the mission of the company from the beginning was to design microsatellites, and that's what I'm going to tell much more about today. So the components of the microsatellites, what we call the modules, some other call them subsystems, are all made in-house. We are actually making the entire microsatellite except propulsion, so I've been very happy to meet a lot of propulsion suppliers at this conference coming by our booth over there and pitching their products. And then we can actually use our modules across a large variety of spacecraft sizes, all the way down to our smaller CubeSats, 10 kilograms, and all the way up to more than 100 kilograms. So, a little bit about the company here. As I said, we were founded in 2015. We have been fast growing in the last couple of years. Today we are around, it's on the pitch here, it says 30 employees. We are actually 35 now. And the target is that we will be around 55 people by the end of this year. We are a good mix of young and old engineers with a combined experience of more than 250 years. Within the space industry. And right now we are actually very close to launching our, what we believe is the first CubeSat or 16U small spacecraft for GEO. Later this year, I've seen many of you coming by our booth and seen a model and mock-up of that spacecraft. So we are very excited to see that going to take place this year. And we're actually building a few more of those for other suppliers. So we really hope that this will take off. Anyway, I have tried to, with this slide, to picture how we see ourselves positioned in the space market. You are probably all aware of the term new space, old space. What we believe, we are actually between those, so we are actually, well, positioned right in the middle there. So in the top part, you can see from a traditional point of view, we call about new space. We had a lot of university startups over the last, let's say, 10 years that have. First, they made small CubeSats, and later on, they have said, okay, they need to go bigger, and they have some problems in taking the modules for very small CubeSats and scale them up to microsatellites. That's not an easy task. Then we have more traditional, called the old space world, where we are Airbus, for instance, Thales, and so forth, building huge spacecraft, several tons, with all the grade 1 components following ESA's, ECSS standards and so forth. That's not an easy task, actually, to take the old space hardware, scale it down to microsatellites. So that's where the founder of Space INVENTOR, Carl Koos, took the decision in 2015 to say, okay, I want to create a company that position ourselves between the CubeSat world and the big sat world. And instead of designing for the very small CubeSats, no, we will design something that is scalable and can be used across, platforms all the way down to around 10 kilograms, they say, or less than that actually, and all the way up and above 100 kilograms, without making any redesigns from mission to mission. We are not a company that has satellite platforms on stock. No, what we do is we have the modules, all the Lego bricks of the satellites will be on the shelf, and then as a customer approach Space INVENTOR for a certain payload, then we size the satellite to adapt to that payload by using all the modules we have, and these modules can be then used for both smaller and larger spacecrafts. So that's actually what you see some example of here. Again, we have modules, what we call modules or subsystems that can fit whatever needs you might come with us and say, okay, we need to support a satellite for, let's say, small 10 kilogram and all the way up, as I just said before. What you see here is actually a true example of our models that we have designed in-house. There on the bottom part there, you see a radio module, and you see computer modules, you see a battery module, you see PowerPoint trackers, power distribution units, and so forth. And everything is contained in its own box, which takes care of the thermal properties, the radiation shielding, and so forth. And I think I want to show you this one here, because this is a good example of how we scale from smaller spacecraft all the way up to, say, more than 100 kilograms here. What you see here is actually a battery package for a 100 watt-hour battery package. So you can imagine a larger spacecraft which requires more battery power. Then you can stack the batteries and then end up in this, what we call a 6 times our standard battery. So you get more than 600 watt-hours. What you also see here is our momentum wheels, which have been sized for both the very tiny CubeSats all the way up to satellites above 100 kilograms. Next one here, I want to show you a little bit about our AOCS equipment. Actually, you see here one of our reaction wheels, 4 reaction wheels here, developed together with VOWare, who's also participating at this conference with a booth back there. You know, when you come to Space Inventor, you can actually come with a very demanding, for instance, Earth observation mission, where you really need high pointing knowledge and high pointing accuracy. So what we have done is we have made some reaction wheels that fits, as I said before, large variety of spacecraft, but they are also very noise-free. The micro vibration level is very low, so they are very well suited for missions that requires high pointing. So what you see here is also what we call the SIST, was a Space Inventor Star Tracker. This is actually one of my babies. I've been working with Star Tracker for quite some years. So if you decide to order a spacecraft at Space Inventor, we can not only point the spacecraft with the reaction wheels, but we also know where we are pointing with our in-house Star Tracker, which is actually, I would say, beginning of life. We really talk about 1 arcsecond accuracy, pitch and yaw, and as some of you might know, the accuracy around roll is about 7 times lower than that. So the bottom line is here that we can actually make both the AOCS sensors in-house and the actuators. So some examples here of spacecraft we have designed so far. We have several different CubeSats here, 3U, 6U, 12U, and the 16U. And the 16U actually, some of you might have seen at our booth, which is the one that's going to be launched later this year. And we are in production of several more of those, and it's going into GEO, and it will go into GEO by direct injection with a Falcon Heavy. So we are very excited about this and really looking forward to make this happen. And then on my final slide, I want to show you that you can also have larger satellites, which is not sent up in a canister. No, these are more traditional microsatellite with a separation ring. And this is just an example of an Earth observation mission or a science mission there, where you have a telescope, a solar array, and then you see on one side there, you see our radio equipment actually can do both S-band for TMTC, but also X-band for if you need high throughput for your payload downlink. You see the 2 star trackers there mounted on the bus. And again, all the modules that goes into this spacecraft here is actually the same type of modules as goes into this smaller GEO spacecraft I talked about before. It's just a matter of if you have more requirements towards power, we add more batteries, we add more solar cell strings, and then more power modules to support that. If you need more processing power, we add more computers. And what I need to emphasize right now is that all these modules are actually connected together via a redundant CAN bus. This actually means that as long as the radio works, and if you want redundancy, you put more radios in. If you want more throughput, you can also put more radios in. But let's just assume that this radio is working. You can actually directly interface from ground all the subsystems on board the spacecraft. It's not a centralized system where you need to have a command and data handling computer where all information goes through. No, you can actually directly from ground, you can communicate, for instance, with a talker rod, a star tracker, the battery module, main computer, all the wheels and so forth, which I believe is it's very powerful actually. So just to recap, all the modules basically have just a redundant CAN bus and a 28-volt input. And if you need more modules, you just plug in more modules for larger spacecraft. For smaller spacecraft, you can just do with fewer of these modules. So let me just recap here. At Space Inventor, what we do today is microsatellites ranging all the way down from about, let's say, 5-10 kilograms all the way above 100 kilograms. So thank you very much. That's what I had to say today.